Hello, I'm here to explain about circular queue. We start from the definition. Circular queue is a linear data structure in which the operations are performed based on FIFO, or first in, first out principle, and the last position is connected back to the first position to make a circle. For the example in a real life, if we always eat something on the breakfast, lunch, and dinner in a day, so we have cycled that activity of it to the next day and begin from breakfast again. In this case, the indexes are breakfast, lunch, and dinner. There are some characteristics in circular queue. Circular queue is a linear data structure, has front and rear, insertion from rear, deletion from front, FIFO or first in, first out. Next, this is the example of circular queue. There is rear and there is front, and in this case, the circular queue is full because we have 5 indexes 0, 1, 2, 3, 4, and then we also have 5 elements 44, 56, 13, 7, and 25. In a normal queue, we can insert elements until queue becomes full, like this. But once queue becomes full, we cannot insert the next element even if there is a space in front of the queue. Next, I will show you how it proceeds. First, we enqueue the 14 and we have front here and the rear is here. And then we enqueue 22. The front is still here. And then the rear is become to 22. And then we enqueue the 13. The front is still here. And then the rear is become to this place. And then we insert NQ minus 6. The front is still here and the rear become to the minus 6. And then if we want to dequeue, we dequeue the 14 first because the dequeue start from the front and the front we change to the 22 and the rear still stay at minus 1. Minus 6, and then we dequeue again the 22 and the front become to 13. And if we want to enqueue again, in this case for the example, we enqueue the 9, so the front is still in the 13 and the rear change into the 9. And then we enqueue the 20. The front is still here and the rear is become to the 20. And finally, to make the circular queue is full, we enqueue 5, so the front is still here and the rear changed from 20 to 5 and the circular queue is full. Now operation is in circular queue. First, front, get the front from item from the queue. Rear, get the last item from queue. And queue, insert the value. This function is used to insert an element into the circular queue. In a circular queue, the new element is always inserted at rear position. And the last is dequeue. This function is used to delete an element from the circular queue. In a circular queue, the element is always deleted from front position. There are some steps in enqueue. First, check whether queue is full. Check rear equals size minus 1 and front equals to 0, or rear equals front minus 1. Second, if it is full, then display Q is full. If Q is not full, then check if rear equals size minus 1 and front equals 0. If it is true, then set rear equals 0 and insert element. And there are some steps in the queue. First, check whether Q is empty, means check front equals minus 1. Second, if it is empty, then display Q is empty. If Q is not empty, then step 3. Check if front equals rear. If it is true, then set front equals rear equal minus 1, else check if front equals size minus 1. If it is true, then set front equals to 0 and return the element. Next, there is a program with C++ language in an IDE program. First, we type include bits standard C++.h, and then we initialize integer rear front, integer size, and integer r. And then we type q integer s, front equals rear equal minus 1, size equal s, r equals new integer array s, void enq integer value, integer deq, void display q. And then we create an element or insert an element, void q and q in value. If front equals 0 and rear equals minus 1, rear equals front percent size minus 1. In first case, value of front is equal to 0 and rear value is equal to size minus 1. Or second case, rear value is equal to front minus 1 percent size minus 1, which means rear equals to the result of that modulo is minus 1 divided by 4 with 0 remainder 4. And then we print f and q is full. Then return else if front equals minus 1, and then we insert the first element on that. And remember, we cannot put 0 or minus 1 in the input of the front element. Front equals rear equals 0, array rear equals to value, else if rear equals size minus 1 and front equals 0, rear equals to 0, array rear equals value, and then else rear plus plus array rear equals to value. And then if we want to delete an element, we just type in q deq in front equals to minus 1. Front value is equal to minus 1. That means the q element is empty. It goes by the first index of the q is 0. And then print f and q is empty, return int min. In this case, if the element of q is empty, thus the value will return to int min. Int min is a syntax to return to the value of minimum integer. And then we type in data equals to array front equals to minus 1. If front equals to rear, front equals to minus 1, rear equals to minus 1. While it is full, the front and rear will add the same value, which means if front is inserted by an element, then the index value will be added to index 0. It happened to rear too. But in this case, it only running on the first element, so that when the element is taken, then the element that was taken is front. And then we type else if front equals size minus 1, front 0, and in this condition is being fulfilled when the queue was loaded at least 3 indexes. The element on the front index will change with the element behind if already taking elements from the queue. And then we type else front plus plus and return data. And then if we want to display element, we type void queue display queue if front equals to minus 1, print f and q is empty, and then return. Print f and elements in circular queue are if rear front for integer I equals to front, print f %d array I, else for integer I equals to front, I is smaller than size, I plus plus, print f %d array I for integer I is equal to 0, I is smaller equals to rear I plus plus, print f %d array I. And then if we want to driver a program, we just type integer main q5 q.nq14 q.nq22 q.nq13 q.nq minus 6, and then display elements present in circular queue q.display q. And then we deleting elements from circular queue, print f deleted value equals to %d q dq, and print f deleted value equals to %d d q dot dq, key dot display q, key dot nq9, key dot nq20, key nq5, key dot display q, key dot nq20, and then return 0. And this is the output of the circular queue that in the IDE program. Element in circular queue are 14, 22, 13, minus 6, and the deleted value are 14 and 22. Elements in circular queue are 13 minus 6, 9, 20, 5, and then the queue is full. There's a time complexity. Time complexity is time complexity of an NQ. The Q operation is O1 as there is no loop in any of the operation. And this presentation is from https geeks4geeks.org. Thank you for watching. I hope you enjoy it.